Welcome to Pavithra Laptop Care. See, the resistors in circuits, this is most important device, means most important component in any motherboard, because you must know what will be the voltage from source to destination in any resistors, any kind of resistors in depending on the circuits. It may be closed or it may be opened. Okay, in that condition, what the result we will get from the resistors, because if you miss any one resistor, the result may vary much variation you will get in the motherboard. Okay, how you will get the variation, that we will check one by one. Okay, now in this video I will open a motherboard schematic and motherboard images. I'll completely explain. Okay, using a motherboard schematic, so complete section today we will see. Now resistors in circuits. SMD resistors. SMD stands for surface mounted device. An SMD is any electronic component that is made for use with SMT. SMT means surface mount technology. Nowadays very thin resistors, thin components are available, okay, to reduce the space of the motherboard. Okay, SMT was developed to meet the ongoing desire for printed circuit board, PCB, which I told you, no, it's a motherboard. Those are PCB. Manufacturers to use smaller components and to be faster, more efficient and cheaper when assembling components to the PCB. See, the motherboard is nothing but a PCB, right? Printed circuit board. On that, very small components if you put, so the size of the laptop also will be very less. So that is the reason very small assembly components are used in PCB. SMD resistor size. See, this is the most important thing, how the size, how you will recognize the size. So there is a code actually. The shape and size of surface mount resistors are standardized with most manufacturers using the JEDEC standards. See, the main thing is this is a standard in maybe worldwide standard or Indian standard. Actually it's a worldwide standard, JEDEC. Yeah, according to this standard only the SMD components will be manufactured. The size of SMD resistors is indicated by a numeric code such as 0603. Any SMD resistors in schematic they will be mentioned. It's a 0603, means that kind of gap will be there on the PCB and that resistor you have to put. Okay, this code contains the length and width. See, 06 is nothing but length and 03 is nothing but width of the package. So the imperial code 0603 indicates a length of 0.060. This is the length actually, inches, and a width of 0.030 inches. Okay, here is the length, width, height. These all are the codes. See, usually for CLR we are using 1206 size, 1210, 1206, 0805. Usually what are the components we are using? 126, 0603, 0402, 0201, now 01 and below. Actually this is the very small one. So what are the wattage capacity, that also it indicates, this table. The main thing is this all indicates the size of the component, resistor size. Next, resistors behavior in circuit. See, you have to give more concentration on this chapter, this topic, because using this only the active components will be working in the motherboard. Any kind of motherboard or any electronic circuits, depending on this characteristics only it will work. So now resistor behavior in circuit, single resistor in a circuit. See, there are two circuits, working circuits I'm talking about. One is closed circuit, other one is open circuit. Closed circuit in the sense there will be a source, the positive and negative. positive will go through a component and the destination part of this circuit will be connected to the negative. That's called complete circuit. Here, open circuit. The source will be connected to the electronic component. Here is in series, and in one part, it's a destination part, or here or wherever it may be, the destination part won't be connected to the negative part. Then we call it as open circuit. It means the source till the destination part it will flow. Okay, but the same or little bit difference voltage we can get it, but it is not completed because it should be connected to the negative. When it's not connected to the negative, then here we will get the source voltages. But once it connected to the negative, here the source voltage will pass through the components and the destination part always will be 0 because it's a complete circuit. What are the voltage will be there? That will be the grounded one. So this is called source and this is called destination when switch is connected connected to the ground. See here 19.5 volts. Any laptop will be using 19.5 volts, usually Windows laptops. Okay, one laptop it will be different voltage, but anyway we will consider it as a voltage, main source voltage. So that one will enter to the resistor. Here 10k resistor has used here. Here first pin number 1 and this one is pin number 2. Pin number 1 is called as a source and pin number 2 is called as a destination. Okay. In case the supply, once this supply goes here, till here it's open circuit, right? So here 19.5 volts you will get. After that, after crossing this resistor, it may be little bit reduced. Okay, here we will get 19.1. Still it is an open circuit only because in case it is connected to next device, then we will calculate as a next device. So till here it's open circuit. In case this one is connected to the ground, then it's called closed circuit here itself. So that time 19.1 volts won't be there, that will be 0 volts. Okay, now it's a continuation part. The destination part is continued to other component. Correct. Here is a load, bulb also a component. So now what will happen? The 19.1 volts will move to the load, to this load. So bulb will glow and finally here will be 0 because the switch will be on condition. Okay, the switch will be on condition, then this voltage directly connected to the ground, then only bulb will glow, otherwise it will be in off condition. Okay, so now you understood the source to the source of the resistor will be 19.5 volts, the destination will be 19.1. In case the destination is connected to the ground, then here it will be 0 volts, but destination is connected to the other component, so other component will glow because the destination is connected to the ground. Okay, so here complete path happened, so that's why here it's a 0 volts when the complete circuit will be there, when the switch is connected to ground. Now in case here is the open circuit, this is the source to source of the resistor will be 19.5 volts usually. The destination of this resistor will be 19.1 because it's already, what is that, one more component is connected in series, that's why. So in case this one is connected to the ground, then it will be complete circuit, but now we are talking about open circuit. The circuit is not connected any component, then here you will get 19.1 are related to this voltage. It's not exact one, it's depending on this value. Okay, so now one more component, here is the bulb. Bulb will be in off condition because here also you will get 19 point something voltage because it is in series. So here it will pass and here also you will get, but I'm not talking about exactly bulb. In case if you are connecting any resistor, one more resistor, then the source will be 19.1. But it depends on the bulb characteristics. Here voltage will be there or not. Okay. In case if it is open circuit, you won't get the voltage, any voltage here. But in case of the component, one more resistor, then you will get 19.1 volts. Here the switch will be open because the negative path is not connected to the positive path. So here you come to know the resistor characteristics in closed circuit and open circuit with a single resistor. Now see, in case actually resistor is a passive component. In case before or after the source of the resistor, before the source of the resistor is connected to the IC, I mean active component, or the destination part is connected to the active component, what will be the voltage? That you must understand. Okay, the main supply is source. Here is the positive and here is the negative. Now the source is connected to the IC, means it's active component. After this IC, it will connect to the resistor, means here till the before the source of this active component, the voltage will be 19.5 volts. Okay, before the source of this IC, 19.5 volts. After this IC to the source of the resistor, the voltage may be vary 0 to 19.5 because the active component has capability to control the voltage and power. Okay, it may control the voltage and power. So that is the reason I am telling it may be 0 or it may be 19.5 or lesser than that or more than that also. Okay, it depends on this IC. Here 19.5 I told, it may be 25 also. Okay, according to the characteristics of this particular IC. Okay, the source will get the voltage. Then according to this, it will pass very little less voltage you will get and other load has connected here. So the load is bulb, then it's a closed one, so that's why bulb will glow. In case here it's a less voltage, bulb won't glow. But here you will get always 0 volts. The complete circuit, the load of the destination is connected to the ground, then always you will get 0 volts, any kind of load component or any kind of component. If the component destination part is connected to the ground, then there will be 0 volts. The source of the particular component is connected to some active components. The voltage of the source of the component is depending on the IC active components. Okay, this is a closed circuit. Here is the open circuit. Now in open circuit, what will be the condition? See here, before the source of this IC will be 19.5 volts or it's a battery voltage. Okay, what are the source we will giving that voltage till the source of this IC will get. After that, destination of this IC and source to the resistor, you will get the voltage according to this IC. Okay, here the destination of this, you will get the same voltage or little less compared to this source voltage. Here is the load will be off condition because it will be in open condition. This one is not connected to the ground. Okay, so now here is the voltage 0. So now it's not 0 because it's not closed circuit. That is the reason here we will get the voltage, same voltage here. Instead of bulb, if it is this resistor, the same or lesser than voltage we will get. Okay, just for example I taken as a load. Load may be resistor also. Okay, now we have seen the voltage across the resistor, open and closed circuit, what it will be. Now we will move with the double resistor. Okay, in case it is two resistors are connected in series, what will be the result? What will be the voltage divider rule in that circuit in case of closed and in case of open circuit? Okay, now the voltage divider will happen only in the closed circuit in case two resistors are connected in series, and the middle of the two resistor we will take it as a voltage divider. Okay, always you remember voltage divider, the source of the first resistor should be connected to the source or supply. Destination of the second resistor or third resistor or so on, the last resistor's source should be connected to the negative part. Sorry, not it's a source, it's a destination part. Okay, the destination of the last resistor, it may be R2, R3, R3, Rn, whatever it may be, the last resistor destination, pin number 2, should be connected to the negative part of the source in closed circuit. Then only we will consider as a voltage divider. For example, R1 and R2 is there. In between, if you take the voltage, then it's considered as a voltage divider. Okay, in case R3 also is there, here you want, that also consider as a voltage divider. The voltage, what voltage you want, it's depending on that. Actually, in voltage divider will be complete circuit. Okay, it's not open circuit, it should be complete circuit. Please keep it in your mind, because in many circuits, many laptop motherboards, you will get these kind of voltages. Okay, especially in charging circuits. So now the source, 19.5 volt source supply is connected to the source of this R1. It means here one thing is understood, the source is connected to the supply. Here destination is connected to the one more resistor, that is R2. Okay, so that's called voltage divider part, but it's not yet completed, correct? The destination part, here is the switch is closed and it is connected to the negative part. It means it's a complete circuit. Then we will consider as a formula. See, V out means here is the voltage divider output. How we will calculate V? V means it's a total voltage, 19.5 volts. See, 19.5 volts. And R2, this one 10K divided by R1 plus R2. We have to add these two and we have to divide by the R2. Then multiply by the source voltage. Then we will get 19.75. Okay, in case it may be 3.3 volts, exactly equal one. It's a, what is that? 3.3 means it's a 1.6 something you will get. Correct. Okay, this is called voltage divider. Which one is not voltage divider? See here, the destination part of the last resistor is not connected to the ground. Then we not consider it as a voltage divider. It may be switch, or it may be MOSFET, or it may be transistor, whatever it may be. That particular component, in case it is not connected to the ground, then we should not connect it as a, consider it as a voltage divider. Okay, in that case what will happen? The source supply will pass here. It will, the destination, the same voltage or lesser than that voltage will pass here, destination part. If we take it as a source, this voltage divider, here 19.2 volts you will get instead of 9.75, because here the destination should be connected to the negative, means ground. Then only we can get it considered as a voltage divider. Otherwise, here there will be no voltage divider. What are the source? Same thing or lesser than that, you will get the voltage. Okay, you got it? See, these two are most important thing, because here in charging circuit there will be logic circuits. Multiple logic circuits has been used because to consider it as an open and closed circuit, because sometimes we need voltage divider, sometimes we have to control the voltage divider. Okay, through the control device we can divide it as a voltage or not voltage divider. Okay, this is most important thing. Now I have taken a motherboard, that is LA-F115P. In this motherboard, what will be the resistor values and what are the resistors work? So one by one we will check. See, this is very simple. Okay, the main thing is, here is a resistor. The source directly connected from the source supply and destination is connected to the IC. The destination part of the voltage is depending on the IC and the source will be same. The source, pin number 1 source, for example, it may be 3 volts. The destination also will be 3 volts in case there is no IC. Because the destination, in case of open, then you will get the 3 volts. Otherwise, the 3 volts is depending on the IC, destination part, what you connected. Okay, the same thing here. See, this is what it is. Here is the PCH. PCH is the active component, right? See, here is a resistor that is connected to the active component, and here is the source. It may be 3 volts. Here is the 3 volts or 0 volts depending on the IC. Okay, In case intermediate is there, then you need to replace this resistor, or this IC may be the faulty. There should not be intermediate. Intermediate means here is the 10K. For example, you have taken as a 10K, but here is the 3 volts, and here you will get 2.8 volts or 2.9 volts, or maybe 0. It should not be 1 or 1.5 because it depends on the IC. In case IC is giving, then it's okay. But IC is taken as the input, then the problem with this component, okay, this I2 component. In that case, we will consider it as a I2 component faulty or maybe resistor faulty. In that case, you need to open this path and you have to check this destination part. You are getting the 3 volts or 2.8 volts. Otherwise, the component is faulty. Okay, now this is the schematic I will take for this particular motherboard, and I will explain the voltage path of this particular resistor. See, multiple resistors. This is very important. What are the resistors as connected? Pin to pin I will explain. Here I have taken schematic. So total 65 pages are there. One by one we will check. This you leave it. We will take only resistor part. Okay, only resistor part. Here 3 volts. Here it is connected to the where? Here it has connected clock, right? So clock CPU DPI 1 clock. Here is the active component. So here you may get 3 volts or maybe 0 volts. Okay, depending on the active components. See, all this same thing. Here also 3 volts always. Here 3 volts always. You will get it or not depending on the active component. See here actually if the source is connected to a supply, then we will call it as a pull up. The destination path is connected to the active components, then we will call it as a pull up. In case the source is connected from the active components and destination is connected to the ground, then we call it as a pull down. Here is the pull down. Here always it will be 0 and here it will be the voltage depending on the active component. Next, here pull down. Okay, one by one I am not going to explain now. That is understood. This is the pull up and this one is the pull down. And here thing else, here is the pull down. Here may be voltage or it may be 0. 100% it's a 0 because it's connected to the ground. Here it may be voltage. It depends on the active component. See, here is the pull up 3 volts Vs, and here the destination pin number 2 may be 3 volts or it may be some other voltages. See, here the IC is giving 0.6 voltage. Using this pull up, here the source is 3 volts but destination part is 0.6 volts because this IC is giving the data. To carry the data using the clock, here is the pull up voltage. The support of 3 volts pull up resistor, this particular signal is going to this particular side, means it's a destination part. Okay, now you understood. Here this IC is connecting to the other IC through this pull up resistor. Here is the 3 volts, but here it should not be 3 volts because it's a complete circuit. This voltage, this path is connecting to the active component. It's depending on the active component's characteristics. Here we can judge the voltage. In case this path is open, then easily we will get 3 volts here also. Okay, now understood. So this is pull down, pull up. Here this 3 volts is going to this path, but no resistor. Here the network resistor. See, network resistor, this we consider as a one resistor, but it has 4 leg. Source, destination, source, destination, source, destination. What capacity? 15 ohms. Here is the source. It's a bidirectional. Here is the source actually. Here the voltage will come and here destination path depending on this circuit. I mean this IC. Means here may be 3 volts or it may be 3 volts or not depending on this active components. Here is the pull up. No, it's not pull up. It's a path actually. In series it has connected. In case here 3 volts is there, then here also you will get 3 volts or 0 volts depending on this path. If it is connecting to the active components, then behavior of that active components you will get 3 volts or 0 volts. Okay. Now here ear to ear is the series connection. So here is the 3 volts, or here also 3 volts or 0 volts. Now here is the pull up 3 volts Vs. Okay, I'll make it big. Pull up 3 volts Vs. Here is the 3 volts or 0 volts depending on this component, connected components. Here 3 volts always PCH. Here also you may get 3 volts always PCH depending on the destination path, or maybe 0 volts. And anything here, see here it is in series, so ear to ear you will get the same voltage or lesser than that, or maybe 0 in case it is connected to the active components. Here is the pull up. Okay, see here one thing I will tell you, this is 4.7, it's the capacity of this resistor, and 0402 the size, I already explained, you know, the size. Here is the size code. See, here is the code 0402. Now you understood 0402 the size length of this resistor. Now it's 150K, it's the value of this resistor, and the size will be 0402. Okay, here is the pull down, but here it's connected to the capacitor. Here is the pull up, it's, see, ash has given. See, wherever you get the ash, there is a logic, maybe 0 or maybe this voltage or lesser than this voltage. Here is a 3 volts, here maybe 3 volts or may not be. Okay, in case of ash. Here 100% it's a 3 volts, and here it's a ground, 100% is a ground. Here voltage divider, see why it's a voltage divider? Here 2 resistors are in series. See, it's a complete circuit. What we have seen here, that one we'll check. Voltage divider rule. See, here is the complete circuit. Here is the ground and here is the positive voltage. Where it is connected? See, here is the source. Here is the 3 volts. Here is the destination 0. In between it has taken. Means here 10K, here 150K. If we do this formula, see, if we do this formula, here is the R1 is 10K and R2 is 150K. See, if you put this formula, here is the 3 volts and here is the 10K and here is the 150K, then you will get the result here. Okay, this is called voltage divider. Here also voltage divider, 3 volts is coming here and here you will get 10 means exactly 50%. Means it's 3 volts, maybe 1.5 volts you will get. Here is the pull up and here is the voltage divider. Board ID always will be voltage divider. Okay, this is called signal. This signal has this voltage. Okay, here it's a pull up. The signal is carrying this voltage. Here it may be connecting to active component, then 0 or voltage. Actually it should be voltage, there should be voltage because there is no ash. If ash comes 100%, it will be logic, means 0 or particular voltage. Here is the voltage divider, here is the complete circuit. Here you are getting the voltage. Here ash is there, then it may be 0 or maybe this voltage divider voltage. Okay, now you got the point, right? So here is the series. Here is the pull up, actually this is a pull up, then it is also pull up. Okay, now in this, here is the network resistor as used. See, here is the input 3.3 volts. Here ash is given, here it may be 3 volts or it may be 0 volts. Here is the pull up, ash is given 0 or 3. Here the same is connected in series. Here may be voltage or maybe not. Here this voltage is connected here. Okay, is 0402 size. Here is the series one. So from here to here signal is passing. Maybe voltage. Here also maybe voltage depending on this. Okay. Now here in series, this RTC cell, the voltage is going through this resistor, 20k resistor. Some little bit voltage may be drop. Here maybe 3.3 and here you may get 2.8 or 2.9 or 3 volts. Okay. Next I'll reduce it. See this voltage RTC cell, actually that is a voltage name, 3.3 volts. Here also you will get 3.3 volts or 0 volts because here ash has given. Wherever the ash has given, there may be a logic 0 or high, low or high. Okay, maybe this one is complete circuit or maybe open circuit, right? In case of it is complete circuit, the ash, it may be complete circuit, then here 0 volts because the destination part of this single resistor. See what I told here, the destination path, in case if it is connected to the ground, then it's a 0 volts. Okay, here all resistor we can check. Here 0 ohms, maybe this same voltage will go here. And what is there here? Here is the pull down. See this 3 volts you may get here, but here 100% 0 volts. Next here is the pull up, 1 volts will get here, and here is the 1 volts or maybe 0 because of ash. The size is 0402. Okay, this is over. Here is the pull up. See 1k resistor as used. Here 3 volts, here it may be 0 or maybe 3 volts. Actually usually 3 volts will come. It depending on this switch, because it is connected to the ground, it will be the complete circuit. And here in series, the voltage, same voltage will come to this, correct? See here is the pull up, this voltage will come to this. Here ash has given 0 or 3 volts. Here ash has given 0 or 3 voltage will enter here. Here is the pull down. Pull down is very important when you are shutting down. So you do the shutdown option, right? In those conditions, this will be in off condition. Okay, this is very important. Pull down. Don't neglect this. Here is the voltage divider. Here is the complete circuit. Here it has taken TPM ID. The source is 3 volts. What is that voltage divider? Here is the voltage divider. The source here 3 volts instead of 19.5 volts. You have to use here 3 volts. And R1 is 10k and R2 also 10k. Okay, 10k, the voltage exact divided voltage will get here. TPM, FTM. Sometimes what will happen, no, here this component won't be there, then only this resistor will be there, then 3 volts is available here. Sometimes this resistor is not available, then only this resistor will be there, then here the source part will be voltage, but here no component, here will be the resistor, then TPM ID, in case voltage will be there here, and here it will be grounded, means 0 volts. Okay, like this component or with component, what will be the voltage? Here the pull up, right? See what are the pull up here voltage, same voltage will come here. It should be there because there is no ash. So here is the pull up, here is the pull down, size 0402. Pull down, pull down, pull down, pull up, next. Here, see the source, maybe one source is 1 volts, here also maybe 1 volts or maybe more than that. It depends on high voltage, where a source or destination, which one is the highest one, that one we will get to destination also. Pull up, these all are depends on this voltage, but this one is depending on active component, it's a 1 volts. Here also 1 volts, usually pull up will be 1 volts, here also 1 volts, but 0 it depending on active component. Here is a pull down. Okay, next. Here see very important one, the resistor is used as pull up and pull down also. Here is the sense ground, sense positive one. Here is the 3 volts, I mean what are the VCC core voltage will be there, that's the 1 volts or 0.3 volts to 1.8 volts, it's depending on the core, that voltage we will get or depending on this path. Okay, sometimes signal will pass, you won't get the voltages. Here is the pull down, it should be 100% complete circuit. Okay, then what will be there? Here it's a signal carrying, it's a pull up, this voltage is carrying by this voltage. Here is the pull up, VDS VID S out bidirectionally carrying by this 1 volts pull up. Okay, don't forget it, it's a pull up. Next, here VCC sense VCC VSS is nothing but pull down, VCC is nothing but source voltage. Okay, this VCC GT. Here source and destination, or destination and source, or source and destination depending on 2 voltage. Now here is the pull down. Here a resistor, here is the resistor, it will connect VCC ST enabled to here, and here the voltage, same voltage is here. The size you can check it here, see 0603, little bit big one compared to other one, compared to 0402, see 0402, the size is 0603, this one is length and 3 is width. Here same. Next, here same voltage, source to destination will vary. See all this, these are the ground, there is a resistor here. See, these are voltage divider or pull up or only the pull down depending on the condition. Okay, see 3 volts always you will get here in case the component is present. You won't get the voltage in case component is opposite. That's it. Here it's connected to ground, there will be no voltage here, because this condition is, it may be resistor or it may be directly jumper. Here is the resistor in series, this voltage will cross from here to here, and this voltage will go from here to some other places. Okay, in this, the condition I told you, no, pull up and pull down. Here it is in series, the same voltage SPD1 TPM will go to this. Okay, or in case of incoming, this voltage will go to this. Here is the pull down. Pull down is very, very important. Here is a resistor. Okay, 1K 0402. Next, here see some logic is there, 3 volts always is coming here, and here also. In case, see, this is very, very important, how I will explain you. Here for example I am taking, here is the voltage 3 volts always. See, here the voltage plus voltage is 3.0 volts. Now this is we consider as a R1 and here is the R2. Okay, the voltage, the characteristics of this component, here is the MOSFET, N-channel MOSFET. In case this N-channel MOSFET gate will get the voltage, then it will connect 1 to 3. Means here it will be series, and this voltage destination will connect to the ground. Then we consider this part as a voltage divider. Then the voltage divider part will go here. Correct. Here is the one, here is the R2. Here is the source part is connected to source and destination part is connected to the ground. In case here there is no voltage, then it will be in open condition. Then we should not consider it as a voltage divider, because I already explained you the destination part should connect it to the ground. Then only we consider it as a voltage divider. In case if it is not connected to the ground, means this open, I already explained you know, it's a depending on the component. Here is the component, if it connects to the ground, then only voltage divider, voltage will go here and this component will work or not depending on the condition. Okay, here it's clear, right? It may be or may not be depending on this. Here, see, this means there may be voltage or it's directly connected to this jumper. Jumper. No, it's not jumper. It's this voltage will come to this. This voltage will come to this. Here is the jumper. Direct same voltage is connected here, but size is 0603. Here the resistors are there. Here input, this signal will go here 10 ohms resistor, or output the here output not there, only input. Here is the output but no resistor. Here is the pull down which is connected to the ground audio jack, and here the network resistor has given, see, these 3 volts will become this one. It's depending on the active component. Internally it is connected to the ground, then complete circuit will happen, then the same voltage is going to ground. In case it is an open condition, then same voltage will go here. Okay, here is a jumper, same thing. Okay, see, same voltage will go here, this particular signals. Here the 100K 0402 size, lid close hash. Hash means it may be 3 volts or it may be 0 volts depending on this active components which is connected to the here destination part. Here is the pull down series, it's jumper. Here series is the voltage divider depending on this. Here is the connected to ground, here is the source, maybe here is the voltage divider. Pull down series, see, here voltage here or here voltage here. Usually this voltage goes here, but size is, see, here is a 0 ohms resistor 0805. Let me check, 0805 size. Okay, this one is, sorry, this one is 0.125 watt. Okay, this is a bigger resistor. Here this is the voltage divider, it's depending on the source. See, this one is connected to the ground, then here a voltage divider you will get. Otherwise here what voltage, 3 volts, 3 volts only you will get. Ground, both side ground. Here is the pull down, the network resistor is going to pull down. What the size here won't mention here, this is the size actually. Network resistor 0804. Here directly series, pull up, series. Here is the ground, here is the voltage divider, right? Here is the source. See here is the source, but voltage divider, see this voltage here directly, it's a complete circuit. You don't have to explain anything, but depending on this component it has given. Pull up, pull down. Here, shall we check it as a voltage divider? No, it's only pull up. This voltage will carry this signal. This voltage will carry this signal. Here one more important, I will tell you. In resistor part I already explained some of the resistors are not constant one, fixed one. Here is the 3 volts always, Here 7.15, it's a fixed one, but this is variable resistor, 100k to 0k. Okay, it will vary depending on the temperature. This one will vary. In case NTC or PTC, whatever it may be, it will vary. When it will vary, the voltage divider, see this one destination is connected to the ground, right? Here is connected to the ground, and here is the source R1, R2. If we consider is the R1, R2 and R3, means it's a 0, means we can consider it as a R2. Then the voltage divider is depending on the temperature. Here it won't be constant. See, that's why in case of thermal related information, we are using this thermistor. Okay, we call it as thermistor. What it is RH1, I will show you in picture, in image. Okay, now we are checking only the schematic thing. So now it's a voltage divider is depending on this. Okay, that is the most important thing. It looks like a coil actually, but that is a resistor. Or here is the network resistor. Here is the series. After this diode, what are the voltage will be there, that will cross this 2.2 resistor, 0402 size. 04 is the length and 02 is the width. See here also resistors. Okay, like this, the same condition you will get the voltage divider or pull up or pull down. Just a minute. See, I'll go a little bit fast. Here series. Here, no resistors. Series. See, in this condition, if it is a ground here, then voltage divider will happen here. But here voltage divider, it has taken. Here is the source, in case of it's a some voltage, and here is the destination part, the divided voltage will get here. Pull up. Here. See, here is the voltage divider again. Because here is the source is this one. What is that? Here is the PSID voltage. In this path, depending on the voltage, depending on this component, you will get the voltage here. For example, it's 3 volts, and here it will be dividing 100k and 15k. Okay, here this part, what are the components are there, the base is depending on this voltage. Okay, here is the source, it's a pull up. Series. See, the resistors are connected in 3 to 4 what is that conditions. One is pull up, other one is pull down, other one is series, only 3. And one more is voltage divider. Pull up and pull down both will be there, then we call it as a voltage divider. Is to pull up. See, the logic is very, very important. This one I'll explain you. Here, how to read? Here there are 2 resistors. Here is the one resistor and other one is here. In case this component is on active, then it will connect 1 and 3. Okay, it will connect 1 and 3. Then this path is called as a ground. Correct. Here the resistor R2, if we consider it as a R2, here is the R1, then we can get it voltage divider. In case this component is in off condition, then the destination is not connected to the ground, then we won't consider it as a voltage divider. See, I already explained you what is that. Here it is. It is the open condition. Here is the open condition. Then the same voltage will pass here. The same voltage will pass here because this is in open condition. There is no ground. If there is no ground, the same voltage will get it. Okay, it's very, very, very important. Depending on this component, the voltage divider will happen. Okay, that's it. The same thing is repeated here. See, voltage divider, you can consider it as a voltage divider because here is input, here is the divider part, and here is the destination part, source, destination, between voltage divider. This component is depending on this voltage. In case if it is a voltage divider, it will depend on this. Okay, what is that component? Later we can check. Now we are talking about the resistor. See, one more, this is the final one. I'll explain you. Here the source, here the what are the voltage is coming here, at one will enter, we consider it as a R1, and here is the R2. The R2 destination should be connected to the ground. The ground is depending on this component voltage will come, then drain to source it will connect, then we consider it as a complete circuit. Here is the 19 volts, here is the voltage divider part. Clear? The same thing is keep on repeating all over the motherboard. All the motherboards, same logic. Pull up, pull down voltage divider. Pull up, pull down voltage divider. That is the resistor policy. In series also, on series. Pull up, pull down, series, voltage divider. These four things are connected. Okay, that's it. This motherboard, we can see the resistors are connected in pull up, or it may be in pull down, or it may be in series, or it may be voltage divider. Got my point? In any motherboard, these are the four conditions of the resistors. That's it, guys. In any motherboard you take, only the four conditions. Once again I am repeating: pull up, pull down, voltage divider, or series. And voltage divider, in case of thermistor, it depending on the temperature. That's it. Now any motherboard if you take, now you are able to do the troubleshooting. I hope so, because completely I explained all the things. What will be the series, what will be the pull up, and what will be the pull down, and what will be the voltage divider. That's it. Whatever it may be the network resistor or normal resistors, or it may be temperature resistors. If any doubts, please contact us. Thank you very much.